Alright, study guide answer key for Unit 3 deals with Pythagorean theorem, volumes of solids, geometric solids, cones, cylinders, spheres, trying to find radius and height or some missing values of volume. Okay. Alright, so we're going to start with the first problem. We're looking here. All these problems that we're going to deal with in these first couple ones are Pythagorean theorem problems. The one thing I do want to point out, please remember that when you see this number on the inside of this problem and it says square, guys, it's already been squared. You do not have to square it again. It is still a squared plus b squared equals c squared. But really, remember, this one is squared, so it's the area of A. Right now it's 22 inches squared plus the area of B, which we don't know because it's the smaller square, so it's b squared, and then the area of the bigger square, see, it says inches squared, so it's already been squared. So on these are just straightforward addition and subtraction. Here, if you know C, if you know the value of C, remember, it's a subtraction problem. All you're going to do is subtract the number. Okay, so for this one, it's already done. So minus 22 inches square, minus 22 inches square. So what we have is b square equals 40 minus 22 is 18 inches square. That is this area inside the box. Okay, remember, when you see the square, it has already been done for. That is the area. Okay. All right, so look at this one. What is the area of the largest square? Well, remember, the largest square is always going to be C. So here, if we do not know C, if you do not know the value of C, then it's going to be a addition problem. You're going to add the two smaller squares together. So it's still a squared plus b squared equals c squared. Well, in this case, it doesn't matter about a or b, because remember, we talked about that 5 plus 2 is 7 and 2 plus 5 is 7. So the order of the smaller ones do not really matter. So 21 inches square, again, that value is already squared, so you do not have to square it again. So 38 inches square equals c square. So remember, it's area of A plus the area of B equals the area of C. Well, here we're just going to add these. 21 plus 38 is 59 inches square equals c square. So that would be the inside measurement of this one. Okay. All right, the distance, we're trying to find the distance here from this point to this point. Well, I have two right triangles, so I'm going to do the Pythagorean theorem twice. I'm going to find two values of C, and then I'm going to just add them together. Okay, so find the value of C for both triangles and then add them together. Add the values together to get your total distance. Okay, so let's see how it works. So for this smaller triangle, this side length of 3 and a side length of 4, we have a squared plus b squared equals c squared. Well, if I plug in the values I know this is C, so I'm looking for C. So we have 3 squared plus 4 squared equals C squared. Okay. Let me plug my razors up just a little bit. So the value of this one, if we put it in our calculator, 3 squared plus 4 squared would be, so 3 squared is 9, 4 squared is 16, gives me C squared. So the value of this point is 25 equals C squared. So kind of like we did up here, this number being squared is actually the area of a square. What I want to know is, what is this leg? So we have to take the square root of both sides, and again, this is going to cancel, so I'm left with C is 5. So the value of this triangle is 5 on the hypotenuse. Okay, let's find the other one. Well, here I have a squared plus b squared equals c squared again. My values here are 6 and 8. So 6 squared plus 8 squared equals c squared. 36 and 64, because 8 times 8 is 64. Let's leave on that on the side. So we have 100 equals c squared. And again, that would be a square on this side of the hypotenuse. That would be that area. but I want to find the side length, so I'm going to take the square root of both sides. So C is going to be 10. All right. So now to find the total distance from A to B, so from A to B, we're going to take these two numbers right here, we add them together. We have 5 plus 10 gives me 15. So the total distance from A to B is 15. Okay, whatever the units are. All right. The next one. Look at line segment MN on the graph. This is the parachute drop that we did in the hallway, and we made our right triangles. So for this one, what I want to do is I want to find where are these two lines. Here, I want to find the distance of this line. So what I'm going to do is try to find where those two lines meet. Well, if I come down this line till I get to the line that the M is on, it's right here. All right, so we can draw our right triangle. And now we just count. 1, 2, 3 is the distance here. And then here, 1, 2, 3, 4, 5, 6. Okay, so we have our side lengths. Now what we can look for is to find the hypotenuse. So you have A squared plus B squared equals C squared. 3 squared plus 6 squared equals C squared. Well, 3 squared is 9, 6 squared is 36, and C squared. We add those two together, we get 45 equals C squared. All right. Now what I want to do now is take the square root. I want to find out what is the square root of 45. Well, we know it's not a perfect square, so we know it's approximately something. But remember, we are having to estimate now because we don't know exactly what it is. So that's where we go back to our number line. The square root of 45, if I was to put on a number line between two perfect squares, well, the one to the left would be 36. The one to the right would be 49. So I know it's between the square root of 36 and the square root of 49. And the square root of 36 is 6. The square root of 49 is 7. So the square root of 45 is between 6 and 7. Okay? Well, let's figure out exactly where it's at. Remember, this is where we make our mixed number. We take the first number. We're going to subtract it from the middle. So 45 minus 36. This is my numerator. Okay, that distance from here to here. That's my numerator. And then the distance from the two perfect squares. 49 minus 36 is 13. So we know it's going to be 6 point something. We just got to figure out what. And again, we're going to round it to the nearest tenth. So we're going to come right over here and we do some good old-fashioned long division. So 13 stays outside. 9 goes inside. Alright, 13 doesn't go into 9, so we go here. That goes 6 times. That's going to be 12. We got to go to the 10th, so we need to go one more place, bring down to 0. 13 goes into 27. I think, if I remember right, it's about 9. So that's going to be 9 times 3 is 27, carry you 2. 9 times 1 is 11. So it's 120 minus 117 is 3. Okay, so we're going to round this up. So 6.69. And since we're rounding to the 10th, this 9 says go up to 6.7. So the best estimate for the square root of 45 is 6.7 ... Okay, so there's your answer for that. Remember, we've got to be able to estimate these. Okay, all right, next one. If z to the third power equals y, what if I want to find the value of z? So remember, we talked about if you are cubing a number. This is z to the third power means we are cubing. Well, the opposite of cubing a number is taking the cube root. So if I want to find this guy right here, all I'm going to do is take the cube root of y. So it's kind of like we put numbers with this. Remember we talked about this. If I do 2 to the third power, if I just say z is 2, then y would have to be 8 because 2 times 2 times 2 is 8. Well, if I want to go the other way and if I want to find out exactly what 2 is, how do I get 2? I just take the cube root of y to get 2. But here's your answer right here. Alright? Alright, number 6. The model of a square with an area of 36 units. Which of these could find it? Well, remember 36 is in here. And remember to find the side length, remember area equals side length, but we take the square root of the area to find the side. Okay, here it is right here, square root of 36. Number 7, if a cube has a volume, a side length of g units, then which expression represents the volume? Well, remember, we're talking volume, we're talking length times width times height. Well, if we have g, we have volume equals g times g times g. Well, that's g to the first times g to the first times g to the first. Kind of goes back to unit 2 right here, where we're multiplying the same base exponents. All we're going to do is keep our bases and add our exponents. So you have g to the third power. Okay, see how everything ties together here? All right, next one. Look at Bob's work. Bob is working on finding the volume of a cone. Well, the first thing I want to know is, I'm looking here. This is important. And the diameter is 8, which means the radius is going to be 4. Well, if I look over here, I know the formula for a cone is volume is 1/3 pi radius square height. Well, if I look automatically, I look right here. What did Bob use? Bob used the wrong formula. Bob used the formula for a cylinder. So Bob used the wrong formula. He used the cylinder formula. He tried to find a cylinder. Okay? So just always pay attention to what we're giving you first. Look for your equations. Look for your formulas. All right, find the volume of a sphere that has a diameter of 8. Well, remember, diameter, a diameter, okay, is twice the radius. Okay, so the diameter is 2 times the radius. It's twice as big. It's twice as large as the radius. Okay. All right. So here, if my diameter is 8, then I'm going to divide that by 2. Gives me 4 for my radius. All right. So here is my radius of 4. All right. So let's find the volume of this sphere. Let's change this color real quick. So I have volume, and remember, for a sphere is 4/3 pi radius cubed. Okay, it says leave your answer in terms of pi, so we're not going to put pi in our calculator. So volume is going to equal, let's see. All right, so we have 4/3 times, and we have 4 to the third power will be 4 times 4 times 4. 85.33. So 85, let me rewrite this. 85.3. Now, it says leave your answer in terms of pi. So what we did, we took this, and we took this, and we left it here. So now the only thing left is pi. So your answer is 85.3 pi. All right. Next one, estimate the diagonal of the rectangle. Well, really, a rectangle is nothing but 2 right triangles. So we can actually block this one off. And what you're actually finding is the hypotenuse. So a squared plus b squared equals c squared. Well, we have 3 squared plus 9 squared equals c squared. And since I can use my calculator, we're going to be using it here. So here we go. 3 squared plus 9 squared gives me 90. So 90 is equal to c squared. And remember, the last step, we want to find the square root of both sides. So we hit 90 and we hit the square root, gives me 9.48. Okay, 9.48. It didn't tell us what to round it to, so we'll go ahead and round that up to the 10th. So 9.5 ... is your value for the length of this hypotenuse. All right. Number 11, find x. Well, x is either going to be a or b. It doesn't matter. The one I do know is it's pointing to the hypotenuse. So remember, we draw our arrow. So a squared plus b squared equals c squared. Remember, these two don't matter. It does not matter which one you plug those in. So I'm going to plug in a squared. I'm going to plug in 9 squared. This is the one that matters. I have to put it in for c. Well, all right, now a squared 9 squared is 81. 12 squared is 144. Alright, so I'm trying to solve for a squared, so I need to move this 81 to the other side. So this is going to cross off. I have 82, I'm sorry, 8 to the second power equals, take your calculator, 144 minus 81. And yes, you can do it in your head, but it's always better to be safe. I see, because I just added instead of subtracted. 84, no, I multiplied, didn't I? Minus, excuse me, 144 minus 81 gives me 144 minus, oh, I keep messing up, sorry. 144 minus 81. Now we got it, 63. Alright, so we want to take the square root of both sides. Sorry about that, guys. So we want to estimate the square root of 63, and we take the square root, 7.9. Remember, dot, dot, dot. I apologize for those mix-ups. Okay? Alright. Next one, we have two cylinders we're going to compare. Well, cylinder X has a radius of 5 and a height of 1. So let's see if we can just freehand this. Okay? So we have a radius and we have a height. So we have a radius of 5 and a height of 1. This is going to be cylinder X, and then cylinder Y. This is going to be a little bit narrower, but a little taller. This one only has a radius of 1, but it has a height of 5. So remember, we did this little activity in class where we talked about which one do you think has a bigger volume. Well, we talked about having a bigger radius means having a bigger volume. So let's see real quick. So we're doing a cylinder, so volume is pi, radius square height. Well, here we know the radius is 5, so volume equals pi, 5 squared times 1. If you put this in your calculator, you're going to get 25 pi. Well, since I'm comparing volumes, I just want to leave, I can compare the first volume, so that's all I need. Alright, let's go find volume for cylinder Y. Alright, so we have volume equals pi, radius square height. Volume equals pi. This time my radius is 1 and my height is 5, so 1 squared times 5. Well, if you put that in, you should get volume equals 1 squared is 1 times 5, so you should get 5 pi. So then it wants us to compare. Well, if I look right here, volume 1 for the X and then volume 1 for the Y, you have 25 over 5. So there's a number of ways to compare this, but the quickest way to do it is just how much bigger is this one? How many times bigger is this one? So what we want to write is something along the lines of cylinder X has a volume that is, excuse my sloppy writing, 5 times greater or bigger than the volume of cylinder Y. Okay? And again, that radius was a giveaway, wasn't it? Okay? Alright, a sphere has a radius of 8. Let's just find the volume. It says leave it in terms of pi. So volume equals, remember a sphere is 4 over 3 pi radius cubed. Well, let's just plug in our number. We know the radius is 8. So volume is 4 over 3 pi 8 to the third power. So we have, here we go, 4 over 3 times, oh, let's clear this out. Let's try that again. 4 over 3 times 8. For me, I have to do it this way. Gives me 682.6, which I would round up to 682.7. 682.7. And since it said leave my answer in terms of pi, that's why we didn't put pi in our calculator. So there's my answer. By the way, it should be meters to the third power. or cubic meters, however you want to say it. Okay. Number 14. Cylinder has a diameter of 6 and a height of 8. How many cubic inches will it hold? Leave your answer in terms of pi. Well, remember, diameter is 8. That means the radius is 1/2 of the diameter, which is 4. So my height is 8. So let's just plug it in. All right, so we have cylinder, so volume is pi, radius squared times height. Volume equals pi. The radius is 4, and the height is 8. So it wants to leave it in terms of pi, so we're not going to put pi in our calculator. So we're going to go right over here. So we're going to make 4 squared times 8. So 4 squared times 8 is 128, right? 128 pi. Alright? Uh-oh. I did this one backwards. We got to mess up. Let's regroup with this one, guys. Sorry. You have to watch because I didn't do what I should have done. I didn't double check. So let's erase this one and let's start over. Sorry. Remember, diameter was 6, not 8. So the diameter was 6, which means my radius was 3. Okay? Gives me a height of 8. Guys, I'm sorry. I do apologize. Alright? So volume is pi, radius square, height. Now I think we got it. Volume is pi, 3 squared times 8. Remember, we're not going to put it in our calculator, so what we should have is 3 squared times 8 should give me 72 pi. That looks more like it. Sorry, guys. 72 pi is the answer for that one. All right. This is where you got to be careful because these numbers sometimes will get to running together and you'll get them mixed up putting them in. So just take your time and double check. Always double check even when you finish. Go back and make sure. That's a great way to make sure you do it right. What is the approximate volume of a cylinder? Has a diameter of 6. I'm going to try it again this time. So this one has a diameter of 6 again, which means the radius is going to be 3 and the height is going to be 2. Alright, this time though it wants me to use 3.14 for pi. So volume equals pi, radius square height, pi, 3 squared times 2. And one more step. I should have done it here, but we can come on one more step. 3.14 times 3 squared times 2. Now that should give us our volume. So here we go. 3.14 times 3 squared times 2. 56.52, and it says round it to the nearest inch. So here we go. So 56.52. Well, this 2 says do not do anything to that 5, just leave it alone. So we're just going to erase it, and now we're 56.5. It doesn't say what my units are, so it will be just units to the 3rd power, or units cubed. Okay? Alright, what's the volume of a cone? Well, first off, right now, what I want to see, I see diameter is 8. That means my radius is half of that is 4. And then I have a height of 4. Alright, cone. Volume is 1/3 pi, radius square height. So plug in what we know. These are the two numbers we're going to be using right here. Okay. Volume 1/3 pi 4 squared times 4. Alright. Didn't tell us what to do on this one. So what we'll do, guys, let's do this. Let's find all 3 volumes since it didn't tell us what to do here. So volume 1, we take our calculator. Remember, we don't put pi in the calculator. So 1/3 times 4 squared times 4 gives me 21.33. So we're just going to round that to 21.3. Remember, pi should be my answer in volume 1. Okay? All right, let's find volume 2. Volume 2 is 1/3. Remember, this one's going to be times the pi button. So 1/3 pi 4 squared times 4. Well, this time we're going to put pi in our calculator. Okay, let's move it over here this time. So we have 1/3 times pi times 4 squared times 4. 67.02. So we're going to leave that one. We're going to round that. We'll leave that one to the hundreds. So 67.02 didn't have anything, so it would be units to the third power on this one. So that would be volume 2. All right, volume 3. Remember, volume 3 is 3.14 substituted for pi. All right, so we have 1 over 3. We're going to take out the pi, put in 3.14 times 4 squared times 4. All right, so let's try 1 over 3 times 3.14 times 4 squared times 4. And remember, hopefully this is going to come out. It should be really close to 67.02. Let's see. Yep, 66.98. So what we'll say is volume 3 is 60. What did I say? 66.9. So this 6, we're going to round this up to the hundreds. So 66.97. Really, really close. These numbers, remember, volume 2 and volume 3 should be very, very almost identical. Should be looking almost the same number, because you're only multiplying a few numbers different. Okay. All right. Number 17. If the diagonal of this square is 6 feet, what's the measurement of the sides? Well, this one is one we worked on. Remember the two-dimensional Pythagorean theorem, 2D. Oops. So this is a two-dimensional. All right. So remember, this is still Pythagorean theorem, because you're still given one measurement. We can find the other one. So what you actually have is a squared plus b squared equals c squared. Well, here I don't know the value of a or b. So what I'm going to do is just plug in that x. So x squared plus x squared equals c squared. And now I can combine this side. I get 2x squared equals c squared. So here's my formula here. So remember the 3 steps that we talked about? Square the hypotenuse, divide by 2, and then find the square root. So square the hypotenuse. So let's plug in what we have. So let's go right up here. Let's erase that. We're going to start right up here. So 2x squared equals c squared. So we're going to plug in what we know. Well, the only measurement I'm given is that one. So 2x squared equals that one. All right, so here's my steps. Let's square the hypotenuse first. 2x squared. Squaring the hypotenuse really means 6 times 6. So that's 36. Next step, square the hypotenuse. Next step is to divide both sides by 2. So I have x squared equals, now 36 divided by 2 is 18. Okay, let's come right up here. And then the last step is to take the square root of both sides. So x is going to be approximately, so we take our calculator, 18, the square root of 18 is 4.24. So x is approximately 4.2 or 4.24, depending on what it asks you to do. So remember the 3 steps. Square the hypotenuse, divide by 2, and then take the square root. Alright, finding the height of a cylinder. Now we've got a little different here. We're looking for height when I know volume. Well, we're talking about cylinders and we're talking about diameter. So what I have is diameter equals 12, which means the radius is going to equal 6, and the volume is 1017.9. So those are the 3 things I'm given, and here are the 2 that I will be using. So we're talking cylinder. So let's fill in our cylinder. Okay, volume equals pi, radius square height. All right. So volume is 1017.9. We have pi, and it says to use the pi button, so we're going to put pi in. Radius is 6 squared and times height. Well, I have different numbers here, so I always like to make mine kind of match. So I'm going to take my calculator real quick. I'm going to put in pi times 6 squared. That gives me a number of 113.09, which is going to round up. We'll just round it up to 113.1. Okay, so we have 1017.9 equals that. Well, I'm trying to solve for h, so I'm going to divide both sides by whatever is not circled. 113.1. This is going to cancel. It's going to leave me with height. Now take this number, put it in your calculator. 1017.9 divided by 3.1. Gives me a height of 9. It doesn't say what height, so just 9 units. Okay, so it's just manipulating those numbers. All right, find the height of a cone that has a radius of 9. So we're looking for a cone has a radius of 9. So I know radius and I know volume. Well, I don't want to fool with the 108 pi. I want to get rid of that guy real quick. You don't have to. I just like to turn all of mine into decimals if I can. Okay, so it gives me 339.29. Okay, so this is going to be 339. We'll just go ahead and round it up to 3. So we're talking cone. So volume 1/3 pi radius square height. We know the volume is 339.3. Now what I want to do here, I'm going to substitute in the 9. So 1/3 pi 9 square h. So let's put this in our calculator. We're going to change that into a decimal. So we have 1/3 times, it didn't say use the pi button. Nope. Yeah, we're going to change this. I'm sorry. 1/3 times pi times 9 square. Should give me 84.82. Okay, so 84.82 height. So this, and this became that. So all we have left is height. So we're going to divide both sides by 84.82. Cross them out. And let's see what we have left. We have our calculator says, oh, I cleared out my calculator, didn't I? Okay. So we have, let's move this over here. 339.3 divided by 84.82 gives me a height of 4.0004, which is really close, so we'll just round it down to 4. So the height of that one is 4. Okay, hang on guys, we're almost done. Okay, last two. Find the radius of a sphere. Okay, 972 pi. So we know volume is 972 pi. What I want to know is, what is the radius? Well, first off, I want to change that. You don't have to, again, it's not mandatory. I just like to get rid of it. 972 times pi, 3053.6. Alright, so here we go. Sphere, 4/3 pi radius cubed. Volume I know, 3056.3. Let's take this now and change this to a decimal. So we can take our calculator. 4 divided by 3 times the pi button gives me 4.188. I'm going to round this up. This 8 is going to tell me to round that to 4.2. So 4.2 radius cubed. Alright. I'm solving for radius, so I'm going to divide by 4.2. So I have r to the third power, r cubed, is 3056.3 divided by 4.2. Gives me 727.6. We'll just leave that as 720. You can actually round it up to 727. Just to the nearest whole number, we're just going to leave it at 727. You can do it at 728. It's not going to matter. Okay. So if we round it up, it'll be 728. So 728 is r cubed. And you take the volume, you take the cube root of that. Remember, this calculator won't do cube roots, but I do know that I can take the cube root to get r. And the cube root of 727 is 9, so this is going to be a little over 9. So we'll actually leave it at 9. So 9 is the radius. Okay. Now the diameter of the sphere for this one, if I know the radius is 9, remember diameter equals radius times 2. The radius is twice as small, so the diameter is twice as big, right? So what I have is diameter equals the radius is 9 times 2. So that means the diameter for this sphere would be 18. Alright? Again, I do apologize for that one question where I wrote the formula, wrote the number in wrong. So that's why it's just real careful. Be careful and make sure that you Double check your work before you turn it in. All right, good luck to go on the test tomorrow, guys.